In this video, we will learn how to use dy by dx, which is the gradient function, to find equation of tangents and normal. So let's first revise the concept of tangents and normal. We can see a curve over here. We have a green line, we have a blue line. Let me pick this green line up and I'll slide it in such a way that it is touching the curve at a particular point. So this green line is a tangent to the curve at this particular point. Let me now pick the blue line, and if I shift this blue line like this, at exactly the same point, this blue line is perpendicular to the green line. So therefore, this blue line is the normal to the curve at the same point. We know that dy by dx, that is gradient of tangent to the curve at a particular point. We can plug that point in and we can evaluate dy by dx. I'm using the symbol m for the slope of tangent. And similarly, I'm using the symbol m with a subscript n for slope of normal. So the terminology slope is the same thing as gradient. We know the rule, gradient of tangent into gradient of normal multiplying to give you -1. This is the rule of perpendicular lines. If two lines are perpendicular, for example, in this case, the blue line is perpendicular to the green line, their gradients multiply to give you -1. We know that gradient of tangent is dy by dx. Therefore, gradient of normal will be -1 over gradient of tangent. I made gradient of normal the subject. This is -1 divided by gradient of tangent. Now let's put this thing to practical use. Let's look at this question. A graph of y is equals to sine 2x is drawn. This is 0 and this is pi by 2. We know the rule, y is equals to sine kx. That means k cycles in 360 degrees or 2 pi radians. Since it is y is equals to sine 2x, therefore 2 cycles in 360 degrees, which means in 180 degrees there is 1 cycle, and what we see over here is half a cycle. So therefore half cycle will be in 90 degrees. 90 degrees is known as pi by 2 radians. That is what the labeling over here is. Now, if I want to find equation of tangent to the curve, and the equation of the curve is y is equals to sine 2x at a particular point. Let me choose that point as, for example, this particular one, something like this. Now let me label this point over here as pi by 6. The diagram is not drawn to scale. This is pi by 2, this is 0, the mid value is pi by 4, and somewhere over here is pi by 6. So what we do is that we take y is equals to sine 2x and let's differentiate dy by dx. Sine becomes cosine 2x, 2 comes out and multiplies, that's the rule. When x is pi by 6, therefore 2x is 2 times pi by 6, which becomes pi by 3. And we know that cosine of pi by 3 is half. So in other words, when x is pi by 6, dy by dx is 2 times cosine 2 times pi by 6. 2 times pi by 6 is pi by 3. Cosine of pi by 3 is half. So this is 2 times half, which comes out to be 1. This is the gradient of tangent to the curve. Now, what are we supposed to do? We are supposed to find the y coordinate also. When x is pi by 6, y is sine of 2 times pi by 6. That is sine of pi by 3, which comes out to be root 3 over 2. So therefore, the x coordinate is pi by 6. The y coordinate is root 3 over 2. The gradient of tangent is positive 1. So now we will apply the concept of coordinate geometry to find equation of straight line. Tangent is a straight line. Y minus y1 is equals to mx minus x1. Y minus root 3 over 2 is equals to 1. X minus pi by 6. Leave the answer in this form. That is the equation of tangent to the curve. Y is equals to sine of 2x. That is the first question that we have done. Now let's move to another question. The other question is again about a trigonometric function. And this time we have y is equals to cosine x. What is the rule for cosine x? Y is equals to cosine kx. That means k cycles in 360 degrees. Now we know that one complete cycle is drawn like this. It starts from 0, it ends at 2 pi, which is 360 degrees in radians. This is pi, and this one is pi by 2. So therefore, the labeling for this x-axis is pi by 2, and this labeling is 0. Now this time, I want to find equation of normal to the curve. What is the equation of the curve? Y is equals to cosine x at the point where x is equals to pi by 3. So now again let me draw a tangent line like this, and it's going something like this. So it's not a scale diagram but a realistic one. This point somewhere over here, this is pi by 3. So the working is y is equals to cosine x. When we differentiate it, dy by dx is equals to negative sine of x. When x is pi by 3, dy by dx is negative of sine of pi by 3, which is negative of root 3 over 2. When x is pi by 3, the y coordinate is cosine of pi by 3, which comes out to be half. So now we have the x coordinate, the y coordinate, which is pi by 3 comma half. The value of dy by dx is negative root 3 over 2, which is the gradient of tangent. Therefore, gradient of normal will be the negative reciprocal of gradient of tangent, which is negative 1 divided by negative root 3 over 2, which comes out to be positive 2 over root 3, which we can further rationalize 2 over root 3 multiplying by root 3 dividing by root 3. That comes out to be 2 root 3 over 3. So now let's go back to the diagram. This green line is a tangent. And over here, if I draw an orange line at this point passing this way, making an angle of 90 degree, therefore this is the normal. and we are finding the equation of this normal. So what do we have? We have the point, we have the gradient of normal, which is 2 root 3 over 3, and last but not the least, using coordinate geometry to find equation of the line. In this case, the line is the normal. Y minus y1 is equals to mx minus x1, y minus the y coordinate, which is half, and this is m, that is gradient of normal, 2 root 3 divided by 3, x minus pi by 3. Leave the answer in this form. This is the equation of normal to the curve y is equals to cosine of x. Let's do one more question, and that question is this. We have y is equals to x minus sine x. This is the equation of the curve. We are looking for equation of normal to the curve at the point pi by 2 and pi by 2 minus 1. So this time the x coordinate, the y coordinate is already given. All we have to do is to find dy by dx. When we differentiate x, we get 1. Minus sign is in between. When we differentiate sine x, we get cosine of x. When x is pi by 2, dy by dx, that is equals to 1 minus cosine of pi by 2. We know that cosine of pi by 2 is 0. So therefore dy by dx equals to 1. Dy by dx is gradient of tangent, that is 1. Therefore gradient of normal would be negative reciprocal of gradient of tangent, which is minus 1 over 1, which comes out to be negative 1. So we have the point pi by 2 and pi by 2 minus 1. We have gradient of normal to the curve, that is negative 1. And we apply the concept y minus y1 is equals to mx minus x1, y minus pi by 2 minus 1. This is in brackets. This is equals to mx minus x1. And we can do a bit more of simplification in this question. So this is y minus pi by 2 plus 1. This is minus 1 into x, which is minus x, and this becomes this minus becomes plus pi by 2. So if I make y the subject, that is minus x plus pi by 2 plus pi by 2 minus 1. So y is equals to negative x plus pi minus 1. This is the equation of normal to this curve. So what we have learned in this particular video is that we have revised again how to find the derivatives of trig function and how to use these derivatives to find equations of tangents and equations of normals. We know that dy by dx is gradient of tangent and gradient of normal is negative reciprocal of gradient of tangent.